Alrighty, this part of the BeltSander project, we're going to do the rollers, the caps for the rollers, and the shafts the rollers ride on. And we're going to start with the shafts first. One of the shafts over here has a keyway. I've actually got it shown drawn with two. I'm not sure whether I want one or two in it. So we're going to start with one, see how that works out. If I need to add a second, I will. The rollers are going to be crested or crowned at a rate of an 1/8 inch per foot. This is 6 inches, so the total would be a 16th, but actually I want a crown in the middle, so it's a 32nd aside. And we're just going to take that down. We're going to do that on the lathe. The caps are made out of steel, so it shouldn't be a problem. And that's about it. So I'm going to head over first. I've got to dimension the lengths of these shafts, and then we'll head over to the lathe and put the final dimensions on the shafts themselves. The material I'm using is 4340 chrome moly steel because it's stronger. Probably not necessary, but I'm doing it anyways. I'm going to show you the milling for length because I'm just doing an unusual technique to cut these to length. A lot of people just toss them in the lathe, but I want to be able to measure them and remove material slowly, so that's what I'm going to do, and I'll show you how I'm going to do it. All right, so the way I'm measuring this is I've got this sitting on my Kurt vise so I can set the calipers flat on the face of the Kurt vise to know that they're not rocking, at least this way. And then I come in and I hold the jaws very flush to the part that I'm measuring. And right now I'm at 11.420, and I need, that means about 7.7 thousandths more. Not that I need anything that precise, but we're just taking side milling passes off this to get it down. Makes these really nasty needles. This material is 4340 partial hard, so I think it's Rockwell in the 20s, and you can't take big bites. Anyways, I'll do one pass here for you to watch. And even though this is carbide, I get some deflection. So this is a conventional milling pass. And when I come back climb milling, it always removes a little more material and eventually gets me to the value that my DRO says. So I basically go back and forth until I don't get any material coming off or any appreciable material come off. 11.4125, and I wanted 4123, except that, you know, can't use calipers to go measuring tenths very accurately, even close. Alrighty, so we need to take this down from 0.75 roughly to 0.5, as close to exactly as we possibly can. Maybe a couple tenths under so that it'll be really good fit for the bearing. So we're just going to take multiple passes here. Let's see, how far can I go in? Oh, looks like just barely with the live center in there. Alrighty, so let's start with 50 thousandths pass. Let's see if we can pull that off. I have a fairly fast feed rate here. I have my DRO set to be 0 at 2.5 inches, which is the end of this. So I'll stop a little bit short of that. Changed inserts, this new Kennametal insert. Looks like a bit better surface finish. All right, so here's my test bearing. Perfect fit, no slop whatsoever. This is a damaged bearing, that's why I'm using it as my test bearing. I squeezed it in place when I pressed it in, and it actually hit on the shield and pressed the bearings into some aluminum directly. But the center part is right on, and so this is exactly 1,000th under. It's 0.499, actually 2 under 0.5. So very nice fit, and we're good to go. So I just need to flip this guy around, do the other side. So the finish last time where it was really shiny was actually a screw up because I had the height of this cutter just a little bit above center and a little bit too much so that it was rubbing, which was causing that shiny part. which seemed so nice, but in reality, it was terrible, causing a huge amount of deflection. 50 thousandths pass at 1120 RPM. Feed rate slow, 2.2 thousandths a revolution. One down, one to go. This one still needs a hole in one of the ends in the 2.5 inch end. It's not symmetrical. I think this is the long end. This is slightly shorter, 2.3125, 2.5. And it gets a hole in there for a pivot point. Moving on to the next shaft. Same for the 1-inch shaft, except that this one has more features. It has a 1/2 inch section on the end. This is the small side, so it's just a really short 1/2 inch section just for the bearing. Then it goes to 3/4 inch section, which then increases up to 1 inch section in the middle. This is the drive shaft, so it will have 2 keyways cut in it. Well, one for start, second one if it looks like it's going to need it. So we're going to do 50 thousandths pass. And we want to speed this up. One side done, flipping it over, doing the second side. Here's a fairly fast feed rate, pretty good material removal, nice surface finish too. 1120 RPM, 9 thousandths a revolution feed rate, 50 thousandths depth of cut. Finish the last side. Pop the part out. Still have to cut the keyways in it, but there we go. There's the other shaft. This is the drive shaft, so there'll be a bushing on this side, a bushing over here, and then 2 keyways, or starting with 1 keyway and the roller in the middle. So there we go. Moving on. So I'm trimming the rollers to length here, and I faced one side, took off a bunch of material to get it close. So I'm finding my 0, which is the face of the chuck here, using the feeler gauge, and call that my 0. Then I need to come over 21 thousandths to compensate for the thickness of the feeler gauge. So we're going to -21. And then we need to come out 5.75. Okay, that gives me a rough approximation. So I think we're gonna part off the majority. And then we'll do a facing cut to get it to length. Alrighty, so I've got another piece of this chucked up in here, and you might be wondering why. It's because I paid a very expensive lesson the first time around with this guy, both pair actually. And the problem is that even though I dialed this guy in each time, I would dial it in here, rotating, making sure that it was as close as I could get it. I couldn't get it more than within plus or minus 5 or 6 thousandths. First important thing to know is that you can't tighten these jaws a ton. They can't be much more than snug. If they're leaving much in the way of marks on the surface, you're clamping too hard and you will deform it. I could put my insert tool that I'm going to eventually use on the inside of this to hold it, and I could have put that in there to stop the jaws from compressing so much. I thought that 1/2 inch material would have been better than that. When I was done, I wanted these to be a nominal 4.75 inches, and the part where I was measuring was 4.75. Then you rotate a little bit around, and now it's off by as much as 8 or 9 thousandths, varying as you rotate width. And even though I pushed, I faced this, pushed it flush up against the jaw face, checked it with my indicator as much as I could, that wasn't seem to work. So I used the same piece and I tried another technique. So what I did is I indicated this in as close as I could, plus or minus like 5 thousandths. If you get it in here, it won't be in here. Nothing you can do about it. If you tap this side in to get this in, then it'll be out here, and they just never the twain shall meet. So what I did was, got it close. I'm going to skim halfway across this guy and make it concentric about an axis. Then I'm going to take and flip this around, dial that part back in again that I just skimmed to be about an axis, getting this other part about the same axis. I will skim that side. Once I've skimmed that side, I will face this guy off as well. Then I will flip it around, dial it in again, face the other side, and when I did that, I got within 1/2 thousandth of length, which is pretty darn good. The diameter still varied by a little bit. This is ultimately going to get crowned anyways, so it really doesn't matter. But at some parts of this, you can't feel the junction from where I skimmed in one direction versus the other direction. And in other parts, it's by as much as like 1/1000th and a half. No matter what I did. This stuff surprisingly deforms so easily. You wouldn't think such thick material would do that, but it definitely does. Lesson learned. Once I get the outsides skimmed in, then I will be able to go to the inside and get it concentric about the same axis, or very, very close. I want it to be very close. I didn't buy ultra precision bearings or anything like that, but I'd like it to get close so that they don't have too much slopping around. So that is what I'm going to do, and I will bring you back when I'm done. Again, the procedure is skim one side, flip it around without facing it, skim the other side, face that side, flip it around again, face the original side, and each step as I move this part, redial it in, both here, going across, and out here as well, so to make sure that it's all dialed in. And when you do that, you have to iterate, by the way. You get it concentric back here, you come out here and it's not concentric, you tap it in by tapping this way, make sure that you do, go another 90 degrees, make sure it's there, because it could be out perfect this way, but not perfect this way. So make sure you do that. When you tap that in, go back and recheck the beginning. It'll often be off by a tiny amount. Dial that back in, come back out here. Without changing the indication, it should be the same out here, and iterate until you get that right, and then you can get pretty decent results. Surprisingly frustrating, but I did learn a lot here. Anyways, I'm sure the experienced among you are laughing. We all got to learn sometime. One final thing, you get this guy all dialed in, it's been clamped in for a little while, it settles as well. And this was within about 1 or 2 thousandths, and you can see now it's got some peaks much off of that. So it also settles. A lot to contend with. You want a precise part in the end. I suspect that if you really want that, you probably need to start with solid and bore it out. Anyways, I'm going to try and make this work. After all said and done, to prevent it from puckering, I used my insert expanding mandrel, and we're going to use that instead. Hopefully I'll be able to do a better job of getting this guy lined up, because it is really fighting me. Alrighty, so I got the two redone, and as you can see, we are really close to 750. It's a tiny bit over, a couple tenths over, which is ridiculous. I don't need that kind of accuracy. I measured at several points, and it's about the same. I was able to blend these in the middle to within about 1/2 thousandth. The one thing that's off now is the center hole is no longer concentric with the outside axis, so I'm going to have to turn that square as well. And so I might have to perturb my my drawing plans just a little bit to compensate. I think I was originally going to take about 50 thousandths off the inside total. That might not be enough to get it square, so we'll see. If it isn't, then I'll adjust accordingly so that I can get the center shaft concentric. I create a register on each side that will be used to align the end pieces, but also the middle is going to catch. Now my concern is that I didn't make this guy big enough to be able to grab on the inside of this with the new larger diameter. I might have to remake this piece. That'll be unfortunate. Alrighty, so now we're ready to bore the inside diameter here for the relief for the end caps that are going to go on here. I'm using my 6-jaw chuck. I reversed my jaws. This is a Schar's 6-jaw chuck, and I'm extremely happy with it. It is a set true chuck, so the first thing we need to do is we need to loosen and leave just snug all of the bolts that attach the jaw to the back plate, or the chuck to the, sorry, not the jaw, the chuck to the back plate, which I pre-loosened some of these. I'm just trying to figure out which ones I didn't. Okay, next up, pop an indicator in. And so, got these screws around here, these Allen screws, and you tighten them to bring that in. And since this was already tightened before, I probably need to loosen the opposite side. Bumped it into gear. Okay, we're about a 1/2,000th now, and that's about as good as I'm getting it. So once I've gotten these screws adjusted, then I come back and tighten all of these. Okay. Now we've locked it against the back plate. These center it. These lock it down. So now leave it in neutral. And I've got just the part lightly tapped in. Let me just make sure it's centered again. Keep bumping the indicator. Okay, and it's out here. So we need to find the low spot, which is right here, and very lightly tap. And there's about 1/1000th, which is extremely good. And just go back here and look, and we're around 1/1000th again. And finally, just need to give the chuck a final snug, because I left it loose so it wouldn't scratch the material. I tapped it around. Very nice. Okay, let's bore out the inside. Theoretically now, when I pop this out and flip it around, this side should be concentric within Schar's claims 1/2,000th, but this material is kind of squishy, even though it's 1/2 inch thick, tends to deform. So I'll be happy if I can get it within one or 2 thousandths. So now we're going to bore in 3/4 of an inch, and we're going to do 25 thousandths passes if we have in gear. I'm going to walk this in. I need 125 thousandths. That was 25 thousandths. Add a little lube this time. Very nice. And we're at dimension. We're going to give it a little bit of chamfer. And we're good to go. And indeed, flipping it over, about a 1/1000th. It's not perfectly cylindrical, and of course, remember, as I said, when you tighten this, it deforms the metal, even though it's 1/2 inch thick. So I'm pretty pleased with the results here. And we got to tap this just a little bit, because this is 4 5/1000ths out, and we would like them to be concentric. And about 1/1000th at this end. Now I can tighten this guy down and bore it. By the way, it's just leaving the tiniest marks on here. You can see some of them here. So there are a little bit, but this is going to be skimmed at an angle. It doesn't matter if it's perfect anyways. It's going to have a belt, a sanding belt go over it, so the finish is not super critical. So I'm just going to bore out this side, do 2 more, and I'll bring you back.